The narrative surrounding the Sukhoi Su-57, positioned by the Russian Federation as its definitive fifth-generation multirole fighter, has increasingly diverged from its ambitious promotional claims, revealing a program mired in profound and systemic failures that collectively paint a picture of a total strategic disappointment. Rather than emerging as a formidable peer to Western stealth aircraft like the American F-22 Raptor and F-35 Lightning II, the Su-57 stands as a testament to deep-seated design compromises, persistent technological shortfalls, and a struggling industrial base, rendering it a questionable asset in the landscape of modern air combat. Its journey from a conceptual competitor to its current, deeply troubled state is a case study in overreach, highlighting a cascade of deficiencies that undermine its every purported advantage. One of the most fundamental and glaring failures of the Su-57 lies in its compromised stealth characteristics, a feature that is the very cornerstone of fifth-generation fighter design. True stealth is not merely a single feature but an integrated design philosophy that minimizes an aircraft's detectability across multiple spectrums, primarily radar. The Su-57, however, appears to be a study in design contradictions. Its airframe, while incorporating some shaping to reduce its radar cross-section (RCS), is riddled with features that betray a lack of commitment to low observability principles. The most frequently cited flaw is the design of its engine inlets and nozzles. Unlike the F-22's serpentine S-ducts, which curve to completely mask the highly reflective engine fan blades from frontal radar, the Su-57's inlets are more direct, relying on a less effective radar blocking device. This is a critical compromise, as the spinning compressor faces of a jet engine are enormous sources of radar reflection. Similarly, the rear engine nozzles are largely exposed and lack the sophisticated shaping and cooling mechanisms seen on their Western counterparts, creating a significant radar and infrared signature that makes the aircraft far more vulnerable to detection and tracking. Furthermore, the overall build quality and panel alignment, crucial for maintaining a smooth, radar-deflecting surface, have been subjects of intense scrutiny. High-resolution imagery consistently reveals visible gaps, misaligned panels, and numerous surface imperfections that create sharp edges and corners, all of which act as miniature reflectors that scatter radar energy back to its source. While fifth-generation aircraft demand microscopic precision in manufacturing, the Su-57 exhibits a standard more akin to a 4.5-generation fighter. This problem is exacerbated by the jet's frequent appearances carrying external weapons on hardpoints. A core tenet of stealth design is the internal carriage of munitions to maintain a clean, low RCS profile. By mounting missiles and bombs externally, the Su-57 effectively nullifies whatever limited stealth its airframe possesses, dramatically increasing its radar signature to a level easily detectable by modern air defense systems. This practice, seen in official Russian media and during its limited deployments, suggests either a lack of suitable internal munitions or an operational doctrine that does not prioritize stealth, fundamentally questioning the aircraft's intended role. Compounding these critical stealth deficiencies is the persistent and unresolved issue of the aircraft's propulsion system. For a fighter to be considered truly fifth generation, it requires advanced engines capable of supercruise, the ability to sustain supersonic flight without the use of fuel-guzzling afterburners. This capability provides a major tactical advantage in both closing with and disengaging from threats. The vast majority of the Su-57 fleet, including all serial production models delivered to the Russian aerospace forces to date, are still powered by the interim Al-41F1 engines. These are essentially uprated versions of the engines found on the Su-35S, a 4.5-generation fighter. While powerful, the Al-41F1 is not optimized for stealth, lacks the efficiency for effective supercruise, and does not provide the thrust-to-weight ratio expected for a next-generation air superiority platform. The long-promised, purpose-built Izdaliye 30 or Saturn 30 engine, which is supposed to deliver the requisite performance, remains trapped in a seemingly endless cycle of development and testing. Despite years of promises and occasional test flights on prototypes, the engine has not been integrated into any operational aircraft and shows no signs of entering mass production. This continued reliance on a legacy propulsion system severely hampers the Su-57's kinematic performance, leaving it unable to match the energy maneuverability and operational flexibility of the F-22 or F-35. Beyond the airframe and engines, the Su-57's avionics and sensor suite, the digital brain of a modern fighter, are widely regarded as lagging significantly behind Western standards. A defining feature of jets like the F-35 is advanced sensor fusion, where data from a multitude of onboard and off-board sensors, radar, infrared, electronic warfare systems, is automatically processed and integrated into a single, intuitive, 360-degree view of the battlespace for the pilot. This provides unparalleled situational awareness. The Su-57's systems are reportedly far less integrated. While it boasts an array of sensors, including its N-036 Bilka AESA radar system, their ability to seamlessly fuse data into a coherent tactical picture is questionable. The crippling international sanctions imposed on Russia, particularly after 2014 and intensified dramatically since 2022, have severely restricted its access to the high-end Western microelectronics, processors, and components essential for building world-class avionics. Consequently, the Su-57's ability to perform in a dense, network-centric electronic warfare environment, sharing data in real time with other assets, remains largely theoretical and unproven, placing it at a severe disadvantage in any confrontation with a technologically superior adversary. The program's developmental and production timeline serves as perhaps the most damning indictment of its failure. What began in the early 2000s, as the PAK-FA program was projected to deliver hundreds of fighters to the Russian Air Force by the 2020s. Instead, the project has been characterized by glacial progress and a litany of setbacks. After its maiden flight in 2010, it took nearly a decade before the first serial production aircraft was ready for delivery, and that very aircraft spectacularly crashed in December 2019 during a factory test flight, just days before its official handover. As of early 2024, after more than 2 decades of development, the total number of serial production Su-57s in service is estimated to be incredibly low, likely numbering in the low 20s. This is a stark contrast to the over 1,000 F-35s, produced and fielded by the United States and its allies. The production rate is anemic, reportedly only a handful of aircraft per year, reflecting a Russian defense industrial complex that is simply incapable of manufacturing such a complex machine at scale, a problem exacerbated by economic constraints and the aforementioned sanctions. This lack of production has been mirrored by a complete failure on the export market. International partnerships are often crucial for funding the exorbitant costs of a new fighter program. The Su-57's most promising collaboration, the fifth-generation fighter aircraft (FGFA) program with India, collapsed spectacularly. India withdrew from the joint venture, citing profound dissatisfaction with the aircraft's performance shortfalls, particularly in stealth and engine technology, as well as disagreements over cost, development timelines, and Russia's unwillingness to engage in meaningful technology transfer. Since India's departure, Russia has failed to secure a single credible foreign buyer. Despite speculative reports and marketing efforts aimed at nations like Algeria, Vietnam, and Turkey, no firm orders have materialized. Potential customers can clearly see the program's struggles and recognize that the aircraft does not offer a reliable or cost-effective leap in capability over proven 4.5-generation alternatives or the far more advanced F-35. Most tellingly, the Su-57's operational record is virtually non-existent, especially in the context of the full-scale conflict in Ukraine, which should have been its proving ground. While Russian officials have made vague claims about the Su-57's use in combat, these have been limited to reports of it firing long-range standoff missiles from the safety of Russian airspace. This is a mission that older, non-stealth aircraft like the Su-34 and Su-35 can, and do, perform regularly. There is no independent evidence of the Su-57 penetrating Ukraine's increasingly sophisticated air defenses or engaging in air-to-air combat. Its conspicuous absence from the front lines suggests a profound lack of confidence by the Russian military in its capabilities. The fear of one being shot down by a Western-supplied air defense system like the Patriot is palpable. Such a loss would not only be a catastrophic propaganda defeat but would also allow Western intelligence to collect invaluable data from the wreckage. An asset that is too valuable or too vulnerable to be risked in the very conflict it was designed for is, for all practical purposes, a failed asset. In synthesis, the Su-57 is not a fifth-generation peer competitor but rather a deeply flawed and compromised platform that fails to deliver on nearly all of its core promises. Its stealth is fundamentally deficient by design and manufacturing standards, its propulsion system is a generation behind, its avionics are constrained by technological and industrial limitations, and its production numbers are infinitesimally small. It has failed to attract foreign buyers and has proven too fragile or ineffective to be meaningfully deployed in a real-world high-intensity conflict. It exists more as a Potemkin jet, a hollow symbol of military technological prowess designed for airshows and propaganda rather than a truly effective instrument of modern warfare. Its survivability against a modern, integrated air defense network is highly suspect, and it ultimately represents a colossal misallocation of resources for the Russian defense budget, a very expensive and very long explanation of a total program failure.